Good afternoon. I will speak you about examples of applications in non-residential buildings for ventilative cooling. So, why ventilative cooling in non-residential buildings? There are many reasons to apply ventilative cooling, but in Switzerland there is one single reason that obliges you to do that. In the new regulations, according to the new Swiss energy law, mechanical cooling is practically prohibited. Why? Because when you build a building in Switzerland, this is a naturally ventilated and cooled gym. We did it before the law because we are a spin-off company of a technical university, so we try to be in advance on the regulations. In the new regulation that Claude-Alain Roulet edited, maybe some of you know him, you have first the obligation to have a perfect solar control. I will speak to you later. Then you have the obligation to provide the opportunity to the users to have a natural ventilation and night ventilation. So your calculations, you are doing them considering that you have the opportunity to apply night cooling. And then there is a third obligation about thermal mass. It is almost impossible to have raised floor and suspended ceilings and cupboards around on the walls, and there is no thermal mass. There should be at least one element with thermal mass according to these new regulations. And if you apply these measures on the building, and you have too much internal gains, then you have additional obligations. Like, for example, if you have more than 30% of glazed surface areas, you have to have automatic blind control, not only manual. And there are some more obligations about thermal mass. It becomes more strict. And then the obligation that kills is that you are not allowed to have more than 7 watts per square meters of electrical energy installed in a building for cooling. And there are some cantons, the new law for the Vaud canton, where Lausanne is there we have our offices. You have the obligation to produce all the electricity that you are using for comfort cooling. You have to produce it with a renewable energy. And you have to take into account that already you have to produce 20% of your electricity needs. So if you use already your roof to produce 20% of your electricity needs, there is no room to produce more for cooling. This is why I tell you it is practically prohibited. Why? Because we know that in Switzerland it is possible to have a cool summer comfort without mechanical ventilation. But as it is not a dictatorial country, they give you the right to luxury behavior if you have the money to invest on solar collectors. So I will try to explain all this. How do we use them? Since many years that we are designing buildings in real buildings. I start with solar control. If you see this graph, which is I took it from the last regulation. Depends on the orientation of the facade, but if you say take the east, southwest, the south, southwest, and west facade, according to the degree of the percentage of glazed facade, it is 0.15, and if you have more than 40% of glazed facade, then you go up to 9% of solar protection. It is almost obligatory to have movable blinds to have these performances. In the north, it's possible to have less. So here is our offices. with this solar protection that can provide you complete solar control, but this is what all the Swiss architects hate, and they don't want to have to their buildings, because as it is obligatory, all the buildings are similar now. It's like this, all the low-cost buildings have these blinds that for some countries, like I was born in Cyprus, it's a dream to have in this hot environment to have these blinds for solar control. In Switzerland, it is obligatory. So I'll show you some other. Is it possible to have less light on this because we don't see the So I'll show you some solar control, which is not the standard one that we can have. Now it is more, I think. So I'll show you how do we some other solutions to go over this outside the Venetian blinds. With these graphics, I show you it is almost impossible. It is impossible to have internal blinds for the south, east, and west facade. We never achieve 9% solar protection. Here you have one of the first eco buildings labeled Minergie in Geneva. We did it in 2003, and you see some facades without blinds, but this is because it is the north facade. So the same building on the west facade, it has another kind of facade with solar shading, and paying attention also to the colors and to the outside environment, so that we have the solar control. And this is the staircase of the building, which is with a glazed roof. And there, if we can just use filters, it's not enough. And there we use some solar collectors to reduce more solar energy going into the staircase. Here it's another building that we designed in Cyprus, in a very hot climate. It is the municipality of Nicosia. It's a new passive building in a Mediterranean climate. There we have the chance that the sun is higher, and we can play with passive shading. So we designed how much the depth of the south facade, and then we are not exactly south. We are 15 degrees. So in the north facade, we had some important. In the northeast facade, we had some important solar gains 2 hours in the morning. So we added some protection also in the north facade, and by combination with passive shading and selective glazings, but paying attention to have enough solar gains for summer. There we almost have no energy for heating because it is enough from these windows to heat the building. We managed to have solar control, but you see, the facades are designed different. The north and the south facade are completely different. We have the chance not to have an east and west facade because there were other buildings. And here we have the real north facade and the real south facade. We managed to get ventilation from the side and to have a fixed glazing. This is a technique that we use very often because now glazing is very huge, it's very heavy to open, so we try to dissociate light from air inlet, and it is very practical. I have a chapter how we design natural ventilation. Here, when I have seen the drawing of this building, this is in Switzerland, he wanted completely glazed. It is a dream. Now we can have walls with a single glazing pane, so the architects are very happy of that. and they would like to have it, but they don't like to have also overheating. But he wanted to put films, but it is impossible to have comfort with only films. Here is the picture that the architect is putting on his website. Here is a photograph that the blind productor is putting on his website. So if you see, we found the architect really didn't want the Venetian blinds. They are ugly. They are everybody is doing that. He wanted tissue. How do you say fabric blinds. I told him, if you have a 2 meters glazing and you have a fabric blind, the people have to lower it up to the end, and all the day they will work like they are in an underground. It is not a good way even for lighting. So we found this idea of taking his blinds and to turn it, and then we always have some light and some view, and we change and we have a perfect external solar protection, and nice, because it's not only performance, it's also aesthetics. This is another building which seemed to be completely glazed. It is seemed to be, but if you see it, yes, it's very nice. It was one of the architecturally, they earned a lot of awards. But if you see it from the inside, this is the structure of the building, a wooden structure, and it acts like a permanent internal solar protection. And as we know, solar protection, internal solar protection is not enough. Then here we used natural ventilation to make this internal solar protection effective by opening on the bottom and on the top, and the heat that enters in the building, it immediately goes out without entering in the space that the users are using. So opening design and ventilation strategies, natural ventilation for cooling is not just openable windows. Openable windows, the rain is going in, the insects are going in, burglary, there is a risk of burglary. It's not possible. Nobody does it. Everybody has openable windows, but we cannot say that they have night cooling. So we should think about the design of openings. Here's a very simple building with 3 levels, and where we use the staircase and some internal windows so that everything is opening, and two windows per story are automatic, so we are not rely on the user's behavior. Here is the gym that I have shown you before. So we take the air in the storage rooms, and the doors are perforated so that the air goes in the inside area. We managed to dimension the inlet and outlet opening so that the neutral level of the building is very high, and we have air going in all the levels. And here is the result. The air is coming from these doors, and is coming from the rooms behind. Doesn't work. Yeah. Yes. So as I don't have a thermal mass in this area, this is the reason I pass the air in the storage rooms, because they are concrete. So I can store it's like an appendix of thermal mass in the main for the main room. And here is the strategy to evacuate the solar gains. Here is the behavior of the building. This is the curve that I told you before, which is the control, the comfort is the EN15251. Here is with night cooling, and here is without night cooling. This is why in the Swiss regulations now night cooling is almost obligatory. So here is the behavior of the building with night cooling and without night cooling. The simulated and the real one are very near. Here is for the building that I have shown you before in Nicosia, we have the town hall, which is a mixed building with activities inside. And here the ventilation strategy is double. We have the natural one that there goes the same path as it takes also with mechanical when the external conditions do not allow to use the external air because it is too hot or because there is not enough stack effect. Here is the design of the openings of this. We have only single-sided ventilation in the offices of the same building. So there is going and it goes from the side of the fixed glazing, and we designed not a single opening so that the user may have different possibilities to open. If it opens one window tilted or one window completely, or both windows tilted or both windows completely, we have between 30 and 600 cubic meters per hour at 5 degrees temperature difference. So we give the possibility to the users to play with natural ventilation according to the needs. So you see, it's not just openable windows. It depends how big they are and how they can open. Here is another building in Switzerland where we also dissociated the fixed window with the openable. This is the north facade of the building. This is why you don't see solar shading. And here is from the inside. You have a very pure line for the view, and you have a separate openable, here it is, and protected ventilation system. Here they are producing watches which cost maybe 10,000 pounds or 15,000 pounds, and they are on the desks, and they are doing natural ventilation with openable windows because we designed the openings to be conform to the needs, and they are doing natural ventilation. Thermal mass. Without thermal mass, all these strategies are not. We use 50% of the potential. So here, for example, we use the anhydride screed and concrete roof. And here is the behavior of we have simulated the heavy. This is in Cyprus, so it is air conditioned in summer because we cannot have only natural cooling. And you see during the weekend, a light building goes up to the external temperature while the heavy building remains cool. Also the stratification strategy. Here we play with the stratification so that we have the cool space there where the people are, and we can accept some more overheating there where there are no people. Here also we use the thermal mass of the staircases and of the offices. Sometimes you cannot have in the 3 stories the same temperature. Here in this 3-story building, these are our measured temperatures. We are always in the comfort zone, although outside it's 34. On the ground floor is very cool and never over 24, and in the last floor we have up to 27. So here are the passive techniques we are usually using. The last slide. So always almost perfect solar shading. Without solar shading, it is nonsense to speak about natural ventilation. You use natural cooling just to to make better the horrible situation with all these heat gains. Thermal insulation, now with the new regulations, almost in every country, buildings are insulated. High apparent thermal mass, optimal dimensioning of building of glazing for passive lighting, heating, and solar protection is not only solar protection. We need heat in winter, and we need light. So it's a trade-off to do for every facade. 70% of natural light autonomy and high efficiency artificial lighting, so that we reduce the solar gains. Opening design for optimal night ventilation, for the summer passive cooling, and control. Many of these low energy buildings, they don't use this. They are very good because they think they have this heat recovery, and they think that this is enough. And they have some openings that they have. They didn't think about them, and it is too hot because there is not appropriate design for summer cooling. So control natural ventilation, not just natural ventilation according to, I don't know what the chance where the architect thought about to put the windows. We use ceiling fans even in Switzerland. And in Cyprus, we came to this colonial architecture now, and the people find very, very interesting to use ceiling fans in combination with air conditioning, so that they use 20 degrees instead of 24 degrees, the set point temperature, and this economizes a lot of energy. And ventilation strategy for automatic windows, or user manual for manual ones. We cannot just leave the building like this. Every apparatus you buy, you have a user manual, but not for the building. If the building is not automatic, if it is automatic, you need a user manual for the person who takes care about the automation, and you need also for the users. The last one, because there are 10 points, this is for the designers. You cannot do all this without simulating. I am 15 years in this job. I don't have the feeling and to believe on my to be confident on my beliefs. I have to calculate at least a rough calculation before I say that this is good or this is bad. Thank you very much.